all integer ordered pair solutions, and we can quickly note the trivial solution of 0, 138. Again, this represents the x-coordinate right here. And of course, the y-coordinate is very conventional in the United States, at least, 138 right here. Okay, and again, by inspection, this would be referred to as the trivial solution, I guess, in some context. Now, notice the order here is important. This is the x-coordinate. This is the y-coordinate. So this is a solution. This is a solution because 0, 0, 138 adds up to 138, right? But 138, 0 would not be a solution, right? So again, ordered pair, it's basic stuff. Now, we're supposed to find all. If we just said find a single solution, we'd be done off to watching a basketball game, right? But we need to check for other solutions. Now, there's a nice, clever approach here that helps you factor this expression. You'll note that just this part right here, 4xy plus y, factors out to this piece right here, all right? But notice what we did. We have 4x plus 1 as a common binomial factor because we chose to add 1 to both sides. You see, this was 138. Now it becomes 139, all right? And notice that you can just think of this as a parenthetical term with a coefficient of 1. Okay, so I'm going to put a 1 there very prominently. That's a 1, all right? Do I need to make my 1s like that? I guess I do. All right, but what that does is, as I mentioned earlier, you factor out the common binomial factor, and you get this. 4x plus 1 is common. This 1 that you see right here is this 1 right here, right? And again, that's when beginners sometimes, I know I go, where'd the 1 come from? You know, but there's a 1 understood in front of any term, right? Okay. Now, notice also a very lucky thing happens right here for us. 139 is prime. 139 is prime. And that's not hard to check. Actually, all you have to do is check all the prime factors less than the square root of 139, but I'll just put is p for prime, okay? Is p for prime. There's a cool check where all you have to do is show that there's no p's. There's no p's that divide, and I'll use some notation here you may have seen. P does not divide in other words, I'm looking at the square root of 139 here, folks. There's no prime factors less than the square root of 139. Okay, so P is not a divisor. There's no P's that divide any number less than the square root. Let me just write that down. The square root of 144 is 12, right? So all we have to do is that we have to write down, maybe I should write this differently. P does not divide the square root of 139. I'm not getting this right. Hang on just a second. Erase. All you have to do is note that there's no prime divisor less than the square root of 139 of 139. Okay, so in other words, I'll write down what are the prime divisors, or what are the potential prime divisors? 2, 3, 5, 7, and 11, right? They're all less than. All of these numbers, these are prime numbers, 2, 3, 5, but I'll leave anything out, 2, 3, 5, 7, 11. Those are the only prime numbers that are less than the square root of 139. This is a result from number theory. It's not hard to prove that at all. But this, all you have to do is test up to the square root. All right, very easy to, you can prove it like there's a composite result, and then the contrapositive of that gives you a prime result. But anyway, none of these divide 139. None of these numbers divide 139. And y'all, that's supposed to be does not divide. So that's the way, none of these prime numbers divide 139, and that assures you that 139 is prime, okay? Sorry for the long-windedness, but it is a test you can do without just looking up on the computer. All right, now, but notice that 139 is going to factor 4 different ways because we are dealing with integers. Integers are the positive and the negative natural numbers along with 0. Okay, so notice here that the case that we guessed, 0, 138, or just did by inspection, okay, that actually falls out in the case 1 times 139 because the only way you can have a 1 right here is if x is equal to 0, right? And of course, if you put 138 for the y, you get 1 times 139 is 139, right? So that solution falls out in this process. But notice the case 139, when you set 4x plus 1 equal to 139, you don't get an integer solution, right? And you can verify that yourself. I think, what do you get? 4 times 35 is 140. 4 times 34 is 136, right? And so there's no integer solution right here. 4x plus 1, I'll just write it, since 4x plus 1 cannot equal to 139 as far as integers goes, right? 4x plus 1 cannot equal to 139. Now, it can if you're allowing for fractions, right? But we're talking integers, all right? Again, we are talking integers. This clearly has a solution, right? A fractional solution. But it certainly does not have, because 4 times 36, I believe, is what? No, it's 4 times, is it 4 times 34? Yeah, 4 times 34 is 136, right? Then 4 times 35 is 140. So you see, this doesn't have any integer solutions, okay? And similarly right here, you can verify that. Notice we have to go the minus root. Now this next one though is the one that's interesting. That is where you're going to get an answer. 4x plus 1, if you set 4x plus 1, this first factor, and again the order is important here, 4x plus 1 equals to minus 139. Okay, that implies if you subtract 1 from both sides, you get 4x is equal to minus 140. And so this would tell you x is equal to negative 35. Minus 35, ladies and gentlemen. Okay. Now, so that means that we know that minus 35 would be the x-coordinate. Okay, now it's easier to see that we need a minus 1 right here, right? So, in order for this to be minus 1, y would have to be negative 2. Okay, so you get 35 times minus 35 and minus 2 would be the other solution, folks. So that's a little messy. We already wrote down one of the solutions, but let's write them both down. What do we get? 0, 138 by inspection and by just going through the process. And I hope you guys see this is a lot easier because 139 is prime. You'd have to go through like 4 cases for each. I mean, it's a little bit of work. So that's one solution, the trivial solution, and also minus 35 too. Minus 35 minus 2. Again, the minus 2 right here would give you a negative 1, which is what you need, right? All right, so minus 2. Okay, so these are our 2 solutions. We found all of them because we know that 139 is prime, and we know that you have to break it up like this and account for the sign changes too. All right, now you may not want to watch the rest of this, but we can check up here. Okay, we claim that minus 35 minus 35 is the x-coordinate, and minus 2 is the y-coordinate as a solution. Well, we have the equation here to check, so let's see how that works out. Okay, y'all. Now, if you put, let's see here, this would be 280, folks. Again, y'all see if I'm getting the arithmetic right. This term would come out to be 280, right? Because minus 2 times 35 is 70. 4 times 70 is 280, right? Now, right here, 4 times minus 35 is minus 140, right? Okay, and then y is minus 2, right? Y is minus 2, and that does equal to 138, right? So we can put a check on this solution. That definitely checks in the original. A lot of times nobody shows this. This just happened to be kind of easy, but 280 minus 40 is 140. 140 minus 2 is 138, and we have both integer solutions, namely 0, 138 minus 35 minus 2. Less than 24 hours till Miami, Denver.